What's up guys, welcome back to Tank Control Games. This is episode 8 of my Resident Evil system series in Unreal Engine 5. And in the last episode we set up our core firing system and improved aiming for fixed cameras. Today we're going to be building on that with shell ejections, bullet decals, tracers, and projectiles. In slow motion you can see all of these effects working together, and when we switch to projectiles you'll see actual bullets firing instead of just the traces. I'm also going to be showing you how to interact with physics objects in the environment and how to destroy these chaos targets. So if that sounds cool, like and subscribe, and if you need to catch up on the previous episodes, they're linked in the description below. So for this tutorial, we're going to be using free assets from Epic's Lyra project, so download Lyra for your engine version and migrate the assets you see on screen now, plus any dependencies. So once you have all of that, let's open up our project and begin. Okay, so when your project loads, just click play and test everything that we set up in the last episode. So previously we set up our up and down aiming, and firing the weapon, it plays a fire animation montage, as well as muzzle flash and impact effects. So that's all still working. So the next thing we're going to do is shell ejection, and we're going to use Lyra's effect for that. So the first thing we can do is go under our master weapon. So navigate to your master weapon, and under the master weapon settings, let's add another Niagara system. So we can just duplicate our impact effect. Let's just call that weapon shell eject, and then just replace the effect with Lyra's, so just search shell. Cool, and then now what we can do is open our samurai edge. So let's find our model and double click it open, and then we have two sockets that we created last time. So we have our left hand socket and our muzzle. We're just going to create one more, and we're just going to call it shell eject. And then for positioning, we'll position this somewhere towards the top where the shell would realistically eject. Okay, so back in our third-person character, we have all of the effects we set up last time. We're going to set this up very similarly, so let's create another function and just call it spawn shell eject. And then this function is going to take in our master weapon again, so let's do input, BP master weapon, and just call it weapon. Okay, so now we want a Niagara system particle component, which we'll be setting after we do our spawn system attached, so we can actually just do it that way. So let's do spawn system attached, and then for the system what we'll do is get our weapon, and then get shell weapon shell eject, and then just hook that up to the system template, and then for the attached to component, what we can do is get our weapon mesh, and we'll attach it to the mesh like that. Then on the return node, just drag off and do promote to variable, and then let's call that shell eject component. And then what we are going to do before we actually spawn the system, check if that component is valid. So let's drag our shell eject component out and do is valid. Then we want to check if it is active, so drag off of the component and do is active component. And then we're going to get a branch. And after we check if the component is valid, we'll also check if it's active. If it's not valid, we're going to spawn it. So drag off of is not valid and hook up our spawn here. And then for spawning to, one other thing we need to do is we need to get the socket location where we want to spawn this. So let's do get socket transform. And then we're going to get it in actor space. And then the in socket name is just going to be what we named our socket here. So shell eject. And then do split struct under your socket transform, and then just hook up the location to location. And then for rotation, we're just going to rotate it 90 degrees. So let's drag off of rotation and do make rotator. And then the yaw is going to be 90. And then do compile, and then for pooling method, just set it to manual release and auto destroy. Cool, and then what we can do after we've set our eject component, just like how Lyra does it, we're going to get our shell eject mesh, and we're going to set that in the Niagara component. So to do that, we need a static mesh variable. So let's create one. So under variables, add a new variable, and then just search for static mesh object reference, and then rename that to just be shell eject mesh. Okay, and now what we're going to do, we're going to set our shell eject mesh that the Lyra effect should use. So a good way to do that would actually be to add that in our master weapon as well. So let's add a variable there for a static mesh. And then let's just call that shell eject mesh. And you can just drag that on top of weapon settings. And then for the actual mesh, let's just set that to be our rifle shell, which comes with Lyra. I don't actually have the specific shell for this gun, but we're just going to use the rifle shell and it'll work just as well. And then back in our function, we want to get that shell mesh, so we can get that off of our weapon, get shell eject mesh, and then we want to set the Lyra Niagara system to use that mesh. So they have a user parameter here called shell eject static mesh, and like we did before, we can set those parameters in our blueprint. So what we can do is drag off of the shell eject component, and then search for set Niagara variable, and then we want the static mesh version of this, and then we're just going to plug in our static mesh, and then we want the exact user parameter from the Niagara effect. So we need to make sure that the name matches this name exactly, but since it is a user parameter, we do also have to add user. So what you can write is user dot shell eject static mesh, and just make sure you spell that correctly or it won't work. And then what we need to make this work is another variable, a boolean, and we're going to call it shell eject trigger. And then let's drag that out, and then right after we set our static mesh, we're going to set this to be false, and then this is going to connect back up with the path off of true. So let's drag off of true and do add reroute node, and then just hook up our set variable to that. Drag your set node out again, and then what we can do to make that work is get our variable and then get a not boolean, and just hook that up to the set. So that will set it to the opposite of whatever was previously set to. Then at the end, what we can do is actually trigger our effect. So we need to get our shell eject component again, and then bring this over here, and then drag off and do set Niagara bool, and you just want the set Niagara variable bool. And then our variable is going to be the trigger in our Niagara system, so it's going to just be user.trigger. And then for the value, we're just going to get our shell eject trigger variable. So what this logic is doing, it's basically just making sure that the Niagara effect only gets spawned once and then reused every time that we fire. So first we check if the tracer component already exists and is active. And if it doesn't, we spawn it and store it as a reference. After that, instead of respawning the system with every shot, we just flip the Boolean trigger. So that's what our shell eject not does. That flip guarantees that Niagara sees a value change even if we fire repeatedly, and as we pass that value into the system as a parameter, that flip guarantees Niagara sees a value change even if we fire repeatedly, and then we pass that value into the system as a parameter to actually make it trigger. And Lyra does this pretty much with all of the effects that they spawn, so at some point it'd probably be good to go back and do this with our impact and muzzle effects, but we'll at least do it for this one for now. So now let's hook up our function. So we go back out a level, and let's add a pin to our sequence node, and then we're just going to drag out our spawn shell eject function. And then let's get our current equipped weapon and just hook that up to the input. So now let's click play and see if this is working. So it might be kind of small on your screen, but our shell eject effects are firing, and we can see the effect kind of bounce out of the gun and then land on the ground. Try to get closer to the camera so you guys can see. Or you know what, I'll probably move the camera up a little bit. And you know what, let's also just really quick just add slow motion input so we can actually like see all of these things as we're creating them. So let's just add the E key, and then we'll just do flip flop. And then on pressed, we'll set global time dilation We did this in another tutorial too, but this is really helpful for just debugging and seeing things working. And we'll set the time dilation to something like 0.4, and then when you press it again, it'll just go back to 1. Okay, so let's see that now. Yeah, that's much easier to see. So yeah, you can see our shell eject is working. Cool, so now that we have that working, let's move on to spawning bullet hole decals. So there's a simple and a complex way to do this. We're going to do like a really uber simple way for now, and then probably going to do a one-off video showing kind of a cool performance thing you can do with spawning decals. But for now, we're just going to do a very basic version of this. So let's do a new function, and we're just going to call it spawn bullet hole decal. And for this function, let's make this take in our hit results. So our line hit result to be exact. So we'll do hit results for our input and just call it line hit result. And then the first thing we can do is get that variable, and let's just split the struct. And then first, let's just check that we have a blocking hit so that we're only spawning this when we do. Actually, that does remind me, let's copy that logic and let's put that in our impact effect as well, which we already have our line hit. So let's actually just make a branch here, but do the same and only spawn our impact effects when you actually have a hit. So we're going to do that. And we're also going to do that under our spawn bullet hole decal. So the next thing that we can do is calculate our spawn location for the decal. So we're going to drag off of our hit normal, our hit result impact normal. Then let's search for project vector onto plane. And then this is actually going to go into the plane normal. And then we want our fire direction for the V here. And to get that, I can't remember if we have gotten it previously. I don't think we did, so I'll show you how to get that now. We got to go back out to our line trace. We can just get our calculate line trace function that we made. Let's store this, I guess, right after doing our first line trace. So what we can do is subtract our end location from our start location, just like that. And then let's normalize that. And then this normalized vector is actually our direction of the bullet firing. So we can just promote that to a variable and just call that fire direction. And we can just hook that up there. So we'll just do that there for now. So if we go back to our function, we can just get that fire direction and plug that into the V. Then let's normalize that after. And I think I misspoke earlier because we're actually going to use this for our rotation. So what we can do is drag off of our normalize and do make rot from ZX. And then we're going to take that impact normal and we're also going to flip that. So let's do multiply by -1. And then that's going to be the X. And then our fire direction with a projected vector onto a plane is going to be our Z. And this is just going to ensure that our decal effect stays flush to whatever surface we hit. So if you don't do this when you fire it against like a wall or the ground, it's going to be rotated the wrong way. So this should fix that. Then let's right click and do spawn decal at location. And then this is going to be the rotation. Then for decal size, I'm going to do something like 5 for now. We'll see if that's too small. And then we want to get the location as well. So our location is going to be the hit impact point added to our hit impact normal. And then just do that multiplied by 1, and then plug that right into location. So then lifespan we'll probably set to 5. And at some point when we get into the more advanced decal spawning tutorial, I'll probably show you how to fade out the decal instead of just popping out of existence, but we're just going to keep it like this for now. Then I think we can just plug our true branch into the spawn, Let's just move this out of the way slightly. And then let's hook up our decal asset. So I have included in the description of this video a texture for you guys to use here. And if you go under bullet holes, we have our T bullet hole. And we can just really quick create a material for this. So let's do create material. Just name it M underscore bullet hole. Okay, so in the material, let's just make it a deferred decal and translucent, and then just hook up the alpha of the texture sample into opacity and click apply. And then if we drag out this decal, it should look something like that. And this is not perfect. This is going to be a really quick and dirty way of doing this, but this is good enough for now. So let's save that texture. Okay, and then we probably are actually going to want to set these materials in our master weapon. Just have them as a variable, so per weapon you can change this, because different weapons will have different bullet effects. So let's add a new variable for a material interface. Just name that bullet hole decal. And then back where we're spawning it, let's get our weapon again. So we probably actually want this to take in our master weapon just like the other functions. Just call it weapon, and then get weapon. And then let's search for our bullet hole decal and just hook that up to the decal material. And then for default in our master weapon, let's just set that to be our M underscore bullet hole material. Cool, so that should be good for now. Let's test if this is working. So let's hook this function up, add a new pin to our sequence, and then let's get our bullet hole decal and just plug that in, and then get our weapon and our line trace. So get line trace, our line hit result, and then get our current weapon. Then do compile, and then let's see if this is working. So click play, and then shoot at the ground. And yep, now you should see our decals are spawning. And then if you shoot at the wall, you'll see they're spawning as well. It's a little dark over on that wall, so we'll shoot the green wall. Oh no, they're right, okay. Yeah, just from far away, they were a little faded. And you'll see after 5 seconds, they just destroy themselves. Cool. So that is working. And then that's our decals done. So we have our shell eject, our decal, and the next thing we're going to do is a tracer. So if you don't know what a tracer is, it's basically that light beam that comes off the gun when you fire. So Lyra has an effect that we can use for that as well. So let's make another function, call this spawn tracer effect. And you may or may not want this effect. I think it's a little much, honestly, especially the Lyra version, but it's totally up to you, and you can modify this effect however you want. Okay, so in this function, let's add an input for weapon, and then we're going to set this up very similar to how we set up our shell eject, pretty much the same flow. So like our shell eject, we're going to need a component for this effect. And you know, we could probably just like, yeah, we can copy all of this actually. So let's copy everything all the way up to the trigger, do Control C, and then let's bring this into our new function. And we're going to replace this shell eject component with one for this tracer. So let's just find that variable for the component, and then just do duplicate, because it's also going to be a Niagara system, and we'll just call this tracer component. And then we'll just swap out anywhere that has shell eject with tracer. And we're going to set this here. And then we're also going to make a variable in our master weapon. So let's find our shell eject, just do duplicate, and just name this weapon tracer. And then find the tracer from Lyra. And then back in our function, instead of weapon shell eject, we're going to do get weapon tracer, hook that up as the system. Everything else can stay the same. Our shell eject socket we still want to rotate it by 90. We're setting our tracer component, And then this won't have setting a mesh here because it doesn't use a mesh, so we're just going to delete that and hook right up into our, right now it's shell eject trigger, but we need an equivalent for tracer. So let's add a, just duplicate our shell eject trigger boolean and name it tracer trigger. And then just swap anywhere that you're seeing that with our new tracer variable. And all I'm doing is just dragging the variable on top of the nodes, and that'll swap it out. So if you didn't know how to do that, that's a decent time saver. And then at the end here, instead of shell eject component, we want our tracer component. And I believe that is everything we need. So actually one more thing. We do need an impact position array, which this effect does take in. So if we actually open our tracer effect, and then we look under our user parameters, we will see that impact positions user parameter, and that's required to make this function. So what we can do is at the end of all of this, we can get the line hit result. So let's actually add another input, hit result, and then just call that line hit. And then let's get that variable towards the back, split it, and then we want to do our line hit trace end, and then do make array. And then we can get our tracer component, and then we can set that parameter by doing Niagara set vector array. And then the array data is going to be from our trace end. And then the parameter name is impact positions. So just user.impact positions. And if that's spelled right, I think that's all we need. So now let's hook up our function at the end here, plug that in, and then again, we just need both of these. So line hit and weapon, and do compile. So let's test if that's working. So if we click play, yep, there we go. So now you're seeing this kind of big beam come out of the gun. And that's basically just what a tracer is. Doing it this way lets you spawn the tracer no matter where you're aiming. And we'll keep it for now, but if you don't like the tracer, something you could do too is just have a branch at the start of this and then just turn the tracer on or off whether you want it. Okay, so that's working. So the next thing that we're going to do is spawning a projectile. And projectiles are optional, I would say. Like, you may or may not want them. I think for just normal bullet firing, they're overkill. Like, unless you're going to do slow-mo and you like need to see the bullets moving. But we're going to set it up, and I'll show you how to use your projectile to also interact with physics objects in the world. And then we'll probably do another function to spawn basically a field that'll affect chaos objects, and I'll show you how to do that as well. So the first thing that we're going to do is make our projectile. So let's go to our main content folder, blueprints, and then let's right click and create a new blueprint class. Just make it an actor and call it BP underscore master bullet. Okay, so our bullet's going to be pretty simple, so let's add a few components. We're going to need a sphere collision. And then we also want a static mesh component. And then you can just call the static mesh component bullet mesh. And then what we can do is get a projectile movement component. And then for the hierarchy, we want our sphere collision to actually be the top of the hierarchy, so just drag that on top of default scene root, and then it'll replace it as the actual scene root. Okay, and then for the sphere radius, let's do something like pretty small, like 5 for now. And then for the default bullet mesh, I don't actually have bullet meshes, so I'm just going to use the rifle shell again. But if you have an actual bullet mesh, definitely feel free to use that. And we'll just rotate that by -90. And then under projectile movement, let's set our initial speed to something like 5,000. And then our max speed also to 5,000. And then let's just turn off gravity scale. And then let's search for rotation follows velocity. And we'll check that. And then initial velocity and local space is checked, and that should be everything we need. So under projectile movement, then we need to set some collision settings. So search for collision, and then for the sphere, let's do block all dynamic, and then we'll do the same for the bullet mesh as well, which it's already set, so that should be good. Then what we want to do on the sphere collision is if we scroll down to the bottom of the details panel, we can find all of the events, and we want to get the on component hit event. And then if you click the plus, it'll just add your event to the graph. And then what we want to do off of here is we want to break our hit result. And then we're going to do, for our projectiles, we're going to check if what we're hitting is a physics simulated actor. And if it is, then we're going to spawn an impulse. So what we can do is drag off of our hit component, and first check is simulating physics, and then do a branch. So we only ever spawn an impulse if we are simulating physics on the thing we hit. And then what we can do is get the hit component, and then search for impulse, and add impulse at location. So the target's going to be the component we hit, and then the location is going to be our impact point. And then the impulse is going to be the velocity of this bullet. So if we just get self and velocity, and then we're going to multiply that by what we want the strength of this hit to be. So start pretty small. Let's try something like 10. And that might be fine. So click compile, and then let's test this. So what we can do, well, first of all, actually, we have to fire this bullet out of our gun. So let's go back in our third-person character, and then we'll make one more function for spawn projectile. Okay, so in this function, what we'll do is just right-click spawn actor from class, and then we're going to get our master bullet, and then we want to use our function for getting the muzzle transform again, and that'll be the location. And then for rotation, what we can do is get that fire direction variable we made before, because we want this to kind of shoot in the direction that we're firing currently. And then do make rot from X, and then just plug that into the rotation. And then everything else can stay at default. So let's just look that up like that. And then let's add a pin to our sequence, and then add this function. So drag our spawn projectile out and just hook that up. So click compile, and then let's test this out. So it is spawning, and the only reason I can tell is it's leaving projectile pinned into the wall, basically shooting it like an arrow. Which also, if you want to make arrows, this is projectiles are a really good use case for it. Like I said, something like bullets, maybe not super necessary. So we can destroy the actor basically anytime we fire our projectile. So let's do a sequence, because you don't want to destroy the actor just on this path, because this only happens if you hit something that's simulating physics. So we'll always destroy the actor if it gets spawned after a little bit of time. So let's just do destroy actor, and let's get a delay. So on our sequence, after we add our impulse off the hit, we'll just destroy the actor after like 0.5 seconds. And that should be long enough for us to get the bullet where it needs to go and spawn our impulse. But we can check, we might have to extend that delay time. So what we can do is create a shape, and let's just make a basic cube. And then for the cube, let's do simulate physics, and then let's give this a mass. So let's give the default 100. And then if we shoot it, you'll see it's adding our impulse. It's a little hard to shoot in fixed camera, but it's adding our impulse, and it's moving the cube. So that's how you can use projectiles to interact using physics with its hit objects. The other thing with projectiles, we can show if you were to have our slow-mo, so you might want to change this to something even smaller, so let's say like 0.2, just so we can see the actual bullets flying. But this will let you see the bullets And you know what, let's turn off our tracer too, just so you guys can see. So we're just going to temporarily disconnect our tracer effect. Click play. And maybe we go even slower because 5,000 is pretty fast for the speed. So let's go even slower on our speed to like 0.1, just so we can really see the bullet flying. Yeah, and there you go. So yeah, it's functioning. If it's disappearing before it gets to like the maximum range, which I don't think it is. I think it's actually working pretty well. So I think that time's fine for now. You'll notice the bullet drops too. If you don't want the bullet to drop and have like a realistic drop, you can just turn off gravity for your projectile, and then that'll just cause the bullet to continue straight in the line that you shoot. But this is what we're going to do for projectiles for now. Okay, so now I'm going to show you how to make our chaos destructible targets. To do that, let's create our sign. So I have this SM zombie target file in the video description for you to download. This static mesh, it won't come in with this material, so you have to import the materials as well. And right now I'm just using this material instance I created off of this zombie target base texture, which when you import the files yourself, all you have to do is set your base color, your roughness, your normal, and your ambient occlusion just in a texture file. I made this texture a parameter just so that I could have these instances that have different textures for each. So I have one for this like zombie doctor, this regular looking zombie, and then Salvador from RE4. So you can set this up the same way if you want. You also don't have to use this at all. You can use whatever you want. This will work with just a random cube if you really wanted to. So the first thing, let's just make sure our target is using complex collision as simple. So under the details, when you open your static mesh, just make sure that's set. Okay, so let's drag our SM zombie target out into the scene and let's scale it up. Something like that should be fine. We'll just see if our character compared to the size of it looks good. Then what we can do is go under selection mode and fracture. And then we're going to create pieces of this mesh to use for the chaos destruction. So what you can do is under generate, click new and make a new geometry collection. And I'm just going to save that under the model for now. And then once you click that, you'll see the mesh turn yellow. And what we can do to actually make pieces of this to fall apart, we can do fracture. And we can either do uniform or cluster. You could do radial as well. Like there's all these different ways to actually break apart a mesh. But for something like a target, I think cluster or uniform is going to work fine. So let's try cluster maybe. So the default settings give you kind of this number of pieces, and you can mess with the min number of clusters, max number of clusters, and the min sites per cluster. So I think the default is probably going to be fine for us just for this test. So let's click fracture. So you'll see it made 91 different pieces. And if you do explode amount, you can see them kind of break apart. So what we're going to do now with our geometry collection is go back into selection mode. And then let's open up our geometry collection. And when you click it open for the first time, it'll ask you if you want to make a data flow object. Just say continue without data flow. And then we can probably keep most of these settings the same. I think the only thing that I'm going to change for now is under collision type. And instead of implicit, we're going to do particle implicit. And then just convex for implicit type should be fine. So let's keep this as this for now. Okay, so our particles are not going to destroy this object right now. So if we shoot it, it'll just knock it over. But what we can do is we can actually destroy it using a transient field. And then let's add one more function and just do spawn field. And then what we can do here is we can have this take in the hit location, and we can break that hit result. And then we need a few things, which we'll have to add it to our blueprint. So the character might not be the best place to add this, but for this test, And since this is kind of just a one-off for fun thing, we'll do it here. So what we can do is under components, add radial fall off, and then also add a field system. And then let's get our radial fall off component and do set radial fall off. And then for the field magnitude, let's just make sure that it's high enough to break our geometry collection. So the max index that's going to break it is this number. So we can just copy this and paste this in our field magnitude. And then for the sphere radius, let's do something like 10. And then the center position is going to be the impact point. And then what we can do is get our get our field system, and then do add transient field. And then just do enable field, and then make this an external strain. And then we'll do this as a field node like this, and hook that all up. Okay, then let's hook up our function. So if we go back out, add one more pin, and I guess we have one unhooked up pin, which was for our tracer effect. So let's we'll just plug that back in. And then under spawn projectile, let's do spawn field, and just hook that up. And then that needs our hit location. So again, just get the line hit result, compile, and then let's click play. Okay, so our sign is getting destroyed, but it's also getting knocked over. So I think one thing we can do to stop that is if we go to our engine and then search for anchor. You can get this fs_anchor field generic. This comes with Unreal. This will lock any of the geometry that's within it and stop it from collapsing. So we'll put this somewhere towards the bottom of the sign just to kind of keep it in place. And then also you do need to choose to use it. So if you search field and do initialization fields and click plus, then you just have to set your fs_anchor field generic, and then it'll just use whatever one you choose for that. So if we click play now it's staying in place, but it is able to be shot and destroyed. And with the size that we're shooting and the amount of damage that we're doing, it's chipping away the sign like this. But you could, if you want, make that field larger or increase the magnitude. So let's add another 0 to our number. And then let's bump up the radius maybe to 20 just so you can see. Do compile and then click play again. And then yeah, now you can see we're kind of breaking apart bigger chunks of the sign now. So I added a few more signs with different textures and just the same method that I showed you before. We add our anchors to the bottom so that they stay in place. But they're all working, and they're pretty fun to mess around with, especially with our Resident Evil 1 style aiming. You can really kind of do your quick aims to try to get headshots. Super fun to practice on the signs. So yeah, those are working really well. But that's going to do it for this video. If you enjoyed it, please like and subscribe. It helps my channel grow. If you have any suggestions for future videos, drop them in the comments down below. And feel free to join the Discord. We have a good community growing there. It's a great place to show off your work or ask questions. So thank you so much for watching, and I'll see you in the next one.